friends, today we are going to study about ionic bonds. So before we learn about ionic bonds, we should understand how electrons are arranged around the nucleus. So electrons are arranged in definite shells around the nucleus which are denoted by principal quantum number n. These shells are numbered as 1, 2, 3, 4 and alphabetically these are denoted as K, L, M and O. Correct? Now, how many electrons a shell can hold? That can be calculated using a formula 2n square. For example, if the shell is K, L, M, N, these are the shell. If the shell is K, that means N equals to 1. Here N equals to 2, here N equals to 3, 4, and so on. So if the N is 1, how many electrons it can hold? According to the formula, what is the formula? That is 2n square. That means maximum 2 electrons it can hold. If the shell is L, then how many electrons it can hold? 2 square 4, 4 into 2, 8. If the shell is M, then 3 square 9, 9 into 2, 18 and so on. Correct? So these how we can calculate how many electrons a shell can hold. Now each shells are again divided into some subshells which are denoted by angular momentum quantum number L. Now this L can have a value up to n minus 1. Now for this, what will be the value of L? If the shell is K, that means N is 1. That means L can be N minus 1 up to N minus 1. So N minus 1, that is 1 minus 1 is 0. So it can have value 0. 0 is denoted alphabetically as S. Okay. If the shell is L, that means N is 2. What can be L? Up to 2 minus 1, that is 1, means 0 and 1. 0 is S, 1 is P. If the shell is M, then up to 3 minus 1, 2. That means 0, 1, 2. This is S, this is P, this is D, and so on. Correct? Now, if we see the structure of SPDF, S subshell is circular in nature, whereas others are dumbbell shaped. These are large sized, heavy, and bulky. We already learned in previous videos that if the shape and the size is large enough, they cause steric hindrance. Those who have not seen those videos, I've already provided the link at the end of this video. Please go and check it once. So these PDF will create steric hindrance, whereas S won't create any steric hindrance because it is small in size. Correct? That means if a molecule is formed by the combination of two atoms involving S subshell, that this bond will be flexible in nature. It can easily twist or turn around, whereas the bond formed due to P, D and F subshells will not be flexible. Correct? Now, one more thing we can understand or see in the structure is this is circular. That means it will get more surface area to form bond with the other atom. Correct? If anything is circular in nature, it will get more surface area to interact with the other atom. But if suppose P is interacting, then how it can interact? This is a P. So if it is interacting with other P, it will interact like this. So it can only interact in these 2 points. Correct? So it will get less surface area. So that means bond formed involving S subshell will be strong as compared to the bond formed involving P, D and F subshell. Clear? Because in the circular will get more surface area, that's why the bond formed involving S subshell will be stronger as compared to the bonds formed involving P, D and F subshells. All these things we already learned in previous videos. So I request for all those who have not seen those videos can go and check it once. Molecules. What are molecules? These are atoms held together by chemical bonds. Bonds can be of two types. Covalent bonds, that means sharing of electrons. And ionic bonds means transfer of electrons. For example, oxygen molecule is an example of a covalent bond because oxygen molecule formed because of sharing of electrons between two oxygen atoms. So it is a covalent bond. If we see the structure of NaCl, So NaCl, Na plus and Cl minus. That means Na is donating one electron and Cl is accepting one electron. As because it is donating, it became plus. It is accepting, it became minus. So Na plus and Cl minus. Here there are no sharing of electrons. They are transferring the electrons. So this is an example of ionic bond. Coming to water, it is also a covalent bond, but because oxygen is more electronegative, this is more electronegative as compared to hydrogen. Therefore, what happened? The electrons they share is shifted more towards oxygen compared to hydrogen. Clear? So water is a covalent, but it is a polar covalent. Why? Because oxygen is more electronegative than hydrogen, due to which the electrons they share is shifted more towards oxygen, and hence it gains negative charge compared to the hydrogen. So oxygen carries partial negative charge, whereas hydrogen carries partial positive charge. Bonds. An important property or character of an atom is electronegativity. What is electronegativity? It is the affinity to attract shared pair of electrons. If we see the periodic table, we'll find that electronegativity increases if we go from left to right, and electronegativity decreases if we go from top to bottom. Now, what are the elements found in the biological system in majority? That is carbon, hydrogen, oxygen, phosphorus, nitrogen, and sulfur. Okay. Where is oxygen in the periodic table? It is here. What I said, electronegativity increases as we move from left to right, and it decreases from top to bottom. So most electronegative element will be oxygen. Next to it will be definitely nitrogen. Next to it will be, can be carbon also, sulfur also. Correct? Carbon and sulfur have almost similar electronegative character. Then next it comes hydrogen and phosphorus, lesser than carbon and sulfur, but among them they are again have the same electronegativity. Clear? So most electronegative element found in the biological system is oxygen, then nitrogen, then sulfur and carbon, then hydrogen and phosphorus. Ionic bonds. This is Na uncle. This is Cl uncle. Now, how many electrons the Na uncle has? Innermost orbital. This is the innermost orbital. K. Maximum it can hold 2. It has 2. Next, outermost orbital. L. Maximum it can hold 8. But how many present? 2, 4, 5, 6, 7, 8 and 9. So this, because of this extra electron, Na is now unstable. So to become stable, it has to donate this extra electron. Come to Cl. Innermost K 2. Next L 8. Next M. Maximum it can carry 18. We already learned this 18. Right? Now this 18, if we talk about L, M is 3. So L can have value 0, 1, 2. This is S, this is P, this is D. S can have maximum of 2 electrons. Here it can have 6. Then 10. How much? 18. Got it? M. Maximum it can hold 18 electrons. Now this 18 will get divided into subshells SPD. S2, P6 and 10 in D. So if it carries 2 electrons, it is stable. If it carries 2 plus 6, 8 electrons, it is stable. If it carries full 18 electrons, it is stable. But how many electrons it has? In this subshell, 2 to 4, then 5, 6, and then 7. So it needs one more electron to become stable. Okay. So Na to become stable, it has to donate this extra electron. Cl to become stable, it needs one more electron to fill this place. Correct? And hence the formation of NaCl. This extra electron from here, Na donated to Cl. Now both are stable. So Na donated became Na plus, Cl accepted became Cl minus. So this is the formation of NaCl, an ionic compound. Now, force and energy of ionic bonds. Generally, it ranges between 40 to 50 kilocalorie per mole. Formula is F equals to K Q1 Q2 divided by R squared D, where Q1 and Q2 are charges, R, distance between ions. D is dielectric constant. To calculate energy, we have the formula W equals to F into D. We can write F into R. In place of F, we can put this formula. This R and this R will be cancelled out. Now E is equals to K Q1 Q2 upon R into D. What is dielectric constant? Dielectric constant means suppose there are two metallic plates, this one and this one. If in between any insulating material is present, for example here water. So the charge stored in this insulating material divided by the charge stored in vacuum or air between the metallic plate is known as dielectric constant. If a substance is having high dielectric constant, that means it can store more charge. If it can store more charge, that means the interaction between charge will become less. Clear? If any substance or any material is having high dielectric constant means it can store more charge. If it can store more charge means the interaction between the charges will become zero. There won't be any interaction between the charges. Now, let's take an example of a daily life. We can easily dissolve salt in water, right? It is very easy to dissolve salt in the water. Why so? Salt is NaCl. Actually, it is Na plus Cl minus. That means these are ions, charged substance. Okay. When we add water in it, the dielectric constant of water is 80. It is very high. The dielectric constant of vacuum is 1. The dielectric constant of water is 80. Right? It is very high, due to which it can store these charges and because of which the interaction between them will break. If Na plus and Cl minus are no more interacting, that means they can't be in a salt form. They'll get dissolved in water and therefore salt dissolves in water. Understood? NaCl is an ionic compound. Na plus and Cl minus, these are charged. When we dissolve salt in water, as because the dielectric constant of water is very high, so it stores these charges and due to which the interaction between them becomes zero. And when these substances or elements are not interacting, they can't be in a salt form. So they get dissolved in water. Now, the same thing it is written here. More dielectric constant, more charge store. More charge storage means less interaction among ions compared to vacuum or air. So the same example, this is salt, NaCl. We able to dissolve salt in water because it store charges. Now, the same thing here explained in some different way. Like, what is happening? To get dissolved in water, this bond should break. Okay, so here bond breakage is occurring. This is what? A crystal, salt crystal. It is known as lattice. So energy stored in this is known as lattice enthalpy. Right? Now, to break this bond, we have to give energy. Right? Then only this bond will break. It won't break by itself, right? It needs energy from outside to break. So that means bond breakage is always endothermic in nature. We have to give energy from outside. Then only the bond will break. So bond breakage is always endothermic in nature. And this energy stored in the lattice is known as lattice enthalpy. Now, when this bond breaks, it now interacts with water molecule. Na is positive, so it will interact with the negative oxygen of water molecule. Cl is negative, it will interact with H positive of water molecule. So now here new bonds are forming. And this energy is known as hydration energy. The energy stored due to the interaction with water molecule is known as hydration energy. And this is new bond is forming here. So bond formation is always exothermic in nature. It will release out some energy. Bond breakage will always endothermic in nature. For example, suppose you and your enemy, you both are fighting. You don't like each other. You want to break his leg. So you have to apply pressure. Now, only a slap won't break anybody's leg or hand. So you have to apply force or pressure or energy from outside to break the other person leg or hand, right? So that means you are putting energy. Because of that energy, your enemy's bone will break. So that means to break anything, you have to give energy, and that substance has to take energy, right? So bond breakage is always endothermic. Now, bond formation. Suppose you enter a new class, you have to make new friends. So you cannot make new friends by sitting in a corner, right? You have to talk, you have to engage with them, you have to communicate with them. So you have to put your energy out. You have to lose your energy. Then only you can form bond. So bond formation is always exothermic in nature. Bond breakage, to break anybody's leg, you have to apply a lot of force or pressure or energy. So bond breakage is always endothermic. It will need energy to break. Okay, clear? Bond breakage is always endothermic in nature. Bond formation is always exothermic in nature. Now, if hydration enthalpy is more than lattice enthalpy, definitely then only the ions or any salt will dissolve. If lattice enthalpy is more compared to hydration enthalpy, then that substance will be insoluble in the solvent. Clear? Understood? You have to answer me and write in the comment section that you have to name one solvent which do not dissolve salt, and you have to give the reason also. Okay, so write this in the comment section, and if you have any doubt regarding anything which we are studying or any life science topic, you can write me in the comment section. I'll try to reply. So if you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, have a good day. Stay safe. Stay happy. Thank you.